get started? Am I audible? Okay, definitely audible. Okay, so I guess we can get started. Is the recording okay? Okay, so let's get started with the. Okay, so this is a Lambda Jakarta kickoff, right?
Yeah.
Okay, so let's kick it off with the most asked question, which is why Clojure? Like why this whole movement had just started, and basically like why everybody's just asked the question, okay, why you guys are even using Clojure? So let's get started with something simple as why not Clojure and where not to use it. So let's just answer the first question, which is basically where you can't use Clojure, and then we'll answer where we can. So let's get started with this. First of all, JVM has a warm-up time. Okay, so definitely you can't use this for Unix daemons like HTTPD or statsd. So this is one of the we built daemons in Clojure, and we found out like one of the daemons used to crash because of JVM warm-up time. So this is one of the common problems which people have. So yeah, it's a general purpose language, but sometimes JVM causes issues. The second one is super low latency real-time stuff. So basically high frequency trading. So if you're into algorithmic trading or something like that, where big companies like DRW or even big banks like Goldman has actually tried this. But over there, again, JVM was one of the biggest issues. And especially with the dynamic language like Clojure, the overall payload on the system used to increase. So CPU bound applications, which is basically obviously like if you're designing a rocket system or any rocket propulsion system, you might want to avoid Clojure over there. The last one is it can run as fast as Java, but again, so the actual benchmarks are actually 1 or 2 milliseconds slower than Java. So obviously with Java 9 and Java 10 you can actually compile to binary, but even after that Clojure still has issues with Java 9 and Java 10 is already out. The last one is maybe high throughput proxies. You can try writing that, but there is a lot of IO bound issues which happens with Clojure, which is basically one of the biggest problems we face is the HTTP requests get serialized and deserialized a lot, especially into Java objects to Clojure objects to then back to Java objects, which is one of the CPU bound operations again over IO. And the last one is don't blame the language, because language is just a language. Language cannot describe stuff. It's always the platform. If you can give me a better platform, obviously the language will run faster. Language is one of the ways to just express the intent. And it's the platform which runs your code. So definitely, so when you're picking up a language, it's always around what platform you want to run it on. So what kind of CPU you want to use, how much CPU do you have, what kind of team you're working with, because that also becomes part of the platform. Are they competent enough to pick up Clojure or something like that? Because again, it's a competency also built over time. And the last one is PLT can be highly, so PLT is programming language theory. And it is highly opinionated, even if it is a theory and it's kind of described as, yeah, it's a theory and like it's written in books. But most of the language designers pick features from PLT, CentaVag, or so it is a bunch of features which you can add to a language, but a lot of features are non-pragmatic. And especially in PLT, the first language people learn is Lisp or Scheme. So yeah, so this is like a lot of disclaimers before we even start with why you pick Clojure. So what are the reasons you might not pick Clojure? And the opinionated part is one of the biggest ones, especially when you're hiring somebody who's a Clojure heavyweight, which is basically had been doing Clojure for a longer time. So now why Clojure? So first of all, it can express intent. This is a valid Clojure code. One of the other reasons is, well, the idea started with something like this. Rich Hickey wanted, well, now we need it, which is basically a list for functional programming, symbiotic with the established platform designed for concurrency. Yeah, it looks like a mouthful, but the reality is we needed something like this, and because the software systems were growing complex, and this had been coming from 25 years of building real-time systems and finding out the pain point of building those systems. So basically, just looked around like, okay, if there is a language already, just like every programmer does. But couldn't find one. So here's Clojure, and that's how everything got started. So Clojure gets started with like, I'm a Lisp. Obviously, you want to express intent, reduce the syntax. You want to pick up something like Lisp. But is a good thing? Well, parentheses are the bad thing, and it's really hard to balance them. But the language has been around before any other language was out there. Even the theory was around before the language even came out to begin with. Lambda Calculus, which was the first language, programming language, just kind of built over mathematics before computer science was even computer science, was basically had a really small code, which is like you start defining your whole system in form of lambda. And to build something on top of lambda is super easy. You only need a couple of definitions to start with. Second thing is Clojure does not almost have no syntax. Like again, this is a valid Clojure code in the sense that if you define these things are almost no syntax. If these things are defined as symbols and this whole thing is an evaluation, then it is a valid Clojure code. And one of the biggest things which came out of Clojure, which is again coming out of Lisp, which is you treat your code as data, because these expressions are treated as lists, and list is a form of collection of data to begin with, and every part of the code we write becomes part of the syntax. And that is a syntactic abstraction. And if it is data, then it can be transferred over wire. So you can do hot patches. And this is coming from all of a sudden we had only a few languages which you can hot patch on the fly. And one of them used to be Erlang, and next one was Clojure. And it got famous just because of that. The last one is there were JVM implementations out there, which is ABCL. ABCL, I don't remember the full form yet. CCL stands for Common Lisp. Kava used to be one of the common ones used in academics. And this is, I'm talking about like 2010, and like around that time, none of the like big languages were like still under construction. And the last one is SISC. This is again like something a research language was kind of, there were a lot of Lisp dialects which were kind of built, but none of them were actually tested on production. And one of the biggest problems used to be, again, the same platform. You can write the same code, run on Clojure, it will run well. The moment you put them to these platforms, you'll have one of the biggest issues. The standard Lisp already have their own platform. So one of the common ones is SBCL, something what called Steel Bank Common Lisp. So this was one of the lists which was kind of used in a lot of banks. And banks were one of the first places which they started using Common Lisp to define one of the complex logics they used to have. This is one of the famous ones, and a lot of Clojure tooling was built around it. So a lot of Emacs bindings and like editor-based IDE extensions were built around SBCL tooling for Emacs, and that's how it got started. Even the first REPL was built on top of SBCL. The next one is defaults to immutability, which is again coming from Lisp, and because of this, Lisp was never adopted in mainstream because of immutability, and it wasn't done performant. Because the initial implementation never used persistent data structures, so it was ridiculously slow, because every time you used to make any modification to data structures, it used to dupe that. And when you're duping a really, really big data structures, it used to grow like crazy. And you have memory leaks and the systems used to crash. And the core data structures are extensible abstractions. So one of the biggest things is you can combine different, so every piece of data which we can define is in form of lists or maps, which is the most simplest way of defining data structures. Later on you can add more modifications to it, even using recursion stacks to define complex linked lists. But again, all of those things come with a cost, and this is where Clojure embraced JVM. Can we do better? Like, this is one of the biggest problems we have, like, because JVM can only give us some performance. Do we have more runtimes for Clojure? Well, that's another question to ask, because the one reason why Clojure was on JVM is to utilize the Java libraries. Um, Now the next thing is functional programming. Is it a good thing or is it a bad thing? Well, we'll know in later talks, but for now we'll just breeze through this. Well, because we get immutable data plus first class functions, which most of the languages now have, but the concept started from functional programming. The next one we have is well, this is the most common thing, which is if the data structures can be mutated, they will mutate. There's no other reason for people to create or duplicate data sets and be safe. And this is one of the biggest problems we have in concurrent systems, which is basically race conditions. Then you end up having logs. The last one is list data structures are structurally recursive, so you can have them as lazy data structures. So you can infinitely store data, and you can only do it when you need it. So it's almost a form of just-in-time data, just like just-in-time compilation. Pure functional languages, so this is another problem we had. So Haskell was already out there, and why people weren't using it, because one of the biggest problems with Haskell used to be hiring programmers. And the other problem used to be it is a statically typed language, and it's really hard to build production systems till to the point somebody came along and built tooling around it. And it's still hard to build applications around Haskell because of the strict type system. And it's not for everybody. Like sometimes you need dynamic language. The last one is data structures are immutable, persistent, supporting recursion. So this is one of the common things. Like you're trying to define a domain in form of data structures, which is ultimately how you're gonna save this. Yes, you can have complex modeling around using classes and object-oriented modeling, but most of the time, object-oriented modeling might not be the best fit for you. And in fact, in a lot of validation systems, you're kind of validating a data structure. The last one is heterogeneous collections and return types. This is kind of an important point. Yes, you can return different types from, basically functional programming normally says that you can return any type. With dynamic systems, you can have heterogeneous collections. But normally it's not a good idea. You always want to make sure that the functions are predictable, because if you're going to return, instead of a list, you're going to return a string. Obviously it's going to cause issues. Yeah, Clojure will allow you to do that, but that's definitely not a good idea to have. Always have your functional contracts clear. But yeah, Clojure will allow you to operate, to return a string, and then later on you might perform a couple of list operations like get, or even append some values to it. The final value might be something which you might not even expect. And there is a dynamic polymorphism, which is basically comes with a def protocol and extension to the language. And these things are more Java interoperability features which was added later on in Clojure code base. One of the biggest things is, or especially when it comes to functional programming or even any functional programming which is going to judge, is immutability and how well is it implemented. And the reality is a good thing, like, because obviously you're going to save in memory, you don't want to mutate the memory in the first place. If the software doesn't change anything, then it's worth nothing. Like it's literally is worthless to begin with. It is a good thing because of this. This was one of the papers which came out in 1993. Henry Baker, so this is a famous computer scientist. They have written a lot of papers, and most of these papers are mostly around mostly targeted programmers. If you're just gonna Google like top 10 papers programmers to read, and this paper comes the first. I'm not going to talk about this paper because this paper is super long, and this whole paper deserves a separate talk. But the idea behind this thing is equal rights to functional objects. The more things change, the more they stay the same. Because TLDR, which comes out of this, is we normally push our state to SQL or no SQL. You like that logo? The last one, the next one is basically like, and you normally bound your state by STM. STM is, again, it sounds like a buzzword, but the concept came out of mathematics. And STM, what we call is software transaction memory. The idea is to build some basic basic operations around memory. So things like atoms, agents. Again, STM deserves a separate talk. I can do some explanation on it, which is basically atoms is one of the ways you make sure that you have atomic changes on the value. Agents are mostly around doing asynchronous updates. There are refs and vars, which is additionally added to STM. And the concept is implemented in most of the functional languages. Haskell is one of the best implementations. Clojure has one of the implementations, which is built on Java threads. And other languages also implemented based on extension to the, even Guava libraries had a couple of implementations for STM atoms. Domain is mostly immutable. If you see, most of the mutations had been pushed to the CRUD level or where you're actually gonna do operations. Where on the domain side of things, you can actually mutate things if you have object equality built into it. And this is where the first part of the paper, which is equal rights of functional objects, makes sense. If your domains can be equated, saying if there was a change between two objects, then obviously you can have immutable objects. Most of there are new paradigms which kind of came after 2010, which is basically events to change state. Browsers started to move towards this. Flux was one of the common examples. Logging-based systems like Kafka were one of the other examples. There are more systems which are like Onyx was one of the systems which was designed around this, which is all the changes are logged and then the states are transferred by applying those logs. And events are triggered on those state changes. When there is a state change, there are new set of events which are going to trigger, and virtual DOM is one of the common examples of that. Which is again, Flux makes an update and virtual DOM gets updated and ultimately the browser DOM. So you're trying to encapsulate the state in form of different abstractions. Lambda architecture is one of the other examples which kind of applies at a grand scale. We are trying to accumulate a lot of system level events and application level events, and as things grow, you make sure that those events are registered and they are kind of at a central place. Lambda architecture came out of Twitter, and they had built a lot of things around this, which is basically analytics, and Facebook also updated their analytics based on the new Lambda architecture. There's a website for Lambda architecture out there, you can read that. And REPL for the win, which is basically, there is REPL means read, eval, read, print, eval loop. So basically, NREPL is one of the REPL systems, which just like Python has a REPL. When you type Python, there is a Python REPL, or when you type Ruby, there is IRB. So same thing, Clojure has NREPL, and you can experiment stuff there. Clojure has a class loader which loads Java classes, so you normally won't have any issues in running any piece of Java code. And is JVM powered. There's 25 years of JVM performance first tooling out there. So when I really want to make Clojure run code fast as Java code, you already have tooling out there. If you have memory leaks, you have Eclipse Mat, which you can use to take memory dumps and actually analyze that. There's interoperability with Java. Java already has enough libraries out there. If you're looking for some library which you want to use, there's already a jar out there which you can directly use with Clojure. And the last one is deployment, just Uber jar it. Uber jar is just gets all the jars into one single jar, and that's it. You just run this Java jar and that Uber jar and just runs. That creates a standalone jar. And next thing comes to is testing. One of the biggest issues we have is are there testing libraries out there? Well, Clojure has a built-in library called Clojure Test, which is already extensive. Other one is Mitch. It is always hard to pronounce that name. This is another library which is written based on facts. This is an extension of Clojure Test. And the last one is Speckle, which is again something like RSpec for Clojure. And this one has most of the RSpec dialects, which is again PDD library from Ruby. And one of the biggest things which we saw in Clojure community was a lot of Ruby developers plus A lot of scheme developers also kind of moved towards Clojure, and that's why we started to see a lot of libraries with two different tastes. So that's why the testing has like 3 libraries by now, and all 3 libraries are well used across thousands of Clojure projects. Well, you want more functional? Yes, the whole reason is because it's functional and you can do function composition. It's easy to model things when you have straight up data structures like list or maps. And it is really fun because you just get a just get a JSON, serialize it, and then start, and it is a map. And now you can do whatever you want to do that a map. You don't have to worry about if it's gonna break any classes when it's deserializing. You don't have any null errors. Well, you will have nulls, but you can actually, because of null punning, you can actually avoid a lot of null errors and do the validation check in first go. And the last one is macros. It is a dark art. It's like only do it like if you really need it. And a lot of Clojure community is against it to use too many macros, and obviously because macros are compile time, so it does not turn the code base into code as data. So when you do macros, it compiles, and when it compiles, it turns into Java style code, which we are always trying to avoid. The second problem with macros is really hard to debug, and debugging with macros is one of the biggest pain points which we run into. And normally you need macros for certain things, which if you want to modify metadata or if you want to add tracers to functions. So by talking about all of this, what do we have by now? So now we have a list. Again, the question we started out with, we have a list for functional programming symbiotic with an established platform designed for concurrency. So this is the first question we started out, and now we have this language. But you'll ask, Ranjeet, I want more. Like, this talk is not enough. I want to know what more Clojure. It's like, I'll say no more. I'm here on the website. I also got a website, by the way. And you say, oh, why is it not HTTPS? Because I'm lazy. It's really hard to do, and it's like a pain to set up HTTPS, man. Like, that's another startup idea. Please, somebody do this. And FI, these are Hickey's pick. So these are a couple of rationale, which and most of the content from this slide is kind of comes from there. And Rich Hickey is really good at explaining the things he wanted to do. And there are 2 articles, which is first one is rationale, which is why Clojure, and the second one is how to deal with state, because this is one of the biggest problems we face in software today. And all the software which runs runs on some state. And there is Lisp legacy. This is from 1990s. This is from Paul Graham. So these are 2 articles around like Paul Graham startup using Lisp, and then the first article is beating the average. The second one is diff, which is again why to use Lisp. But these things are more targeted towards legacy, SBCL, and old Lisp before Clojure was even out there. So there were startups which was built on Lisp. But the only thing is the trade-off comes with that is mostly around how much Lisp you want to use and how well your team is going to glue to that. WhatsApp is another one of the good examples of this. Like WhatsApp, when it started out, the best platform they could find was Erlang. And since they picked Erlang, they've always made sure that the language they're going to pick, they're going to train people when they're doing that. But by the end of that, there were only 20 people handling all WhatsApp load, which is billions and billions of requests. So again, with great power comes great responsibility, and this is what happens. This is Uncle Bob's ranting about object orientation. He always rants about some stuff, so there is always like, so this is functional programming versus object orientation. In the large, which is mostly around how we are treating software these days. Last one is, are we still a programmer or are we doing something else? Are we basically aggregators? These 3 articles are worth reading before you make any judgment about picking Clojure for production. The last one is, there's some random dude who was sharing some love, and he also answered why Clojure. This one is from a data scientist point of view. When they moved towards web development, and the first question was like, do you like Lisp? So yeah, this is the article worth reading. And I'm going to open up for questions, and that's again a valid Clojure code. So, and it's using agent, and I'm an agent there. Okay, I'm going to open up for questions.
Question. Before that, big applause to Mr. Ranjeet.
Yeah.
Yes, if you have questions, you might ask.